Hello class, in this lecture we'll continue learning how to use Simul8 software. Now this is what we have obtained for the MM1Q. Let me close the results manager. And of course you will be able to use the file menu to save the simulation model you have created into your local hard drive and use them later, for instance. Now let's see how we can from this create an MM2 model, which we have learned also in the lectures. To do that, of course, the difference is we need another server. So we click on the activity and place the server, for instance, here. Now, this server has to be connected with the queue because the one queue will serve both servers. And again, the finished jobs from activity 2 to server number 2 will be connected to the endpoint to collect all the jobs, all the finished customers. To do that, we click on this edit routing arrows. Click on it. Move this arrow on top of the queue, your starting point, or the origin of the routing arrow. Single click, left click, and you see it's going to give you a question mark asking you where is the terminal point. So move this to activity 2. This is where this arrow should end. You can see the arrow or the cursor changes the shape. Click on this, and arrow is created. And we repeat this to connect the server with the finished one. Now you can go back and click on this edit routing arrow to cancel the selection. So immediately you have a single stage, single queue 2 server system. It's not necessary MM2. We have to check the parameters. But first, let's start with the arrivals. Now for this system, the arrival will be different. In this case, the arrival process will be 105 jobs per hour. And that means in terms of minutes, the number of arrivals will be 60 over 105. And you can see here, well, you don't have to really do the calculation. You can enter this expression. So 105 jobs per hour, meaning 1 over 105 per hour, or 60 over 105 per minute, which makes it very convenient. For the servers, make sure you choose exponential distribution, and the service time in what we have is 30 seconds. 30 seconds is 0.5 minutes. And this is true for the other one. Okay, we have to choose exponential distribution, and we have to choose 0.5 minutes. Again, the default time unit is minute, so I have to choose 0.5. Now you can change the results collection period of time since the jobs are writing much faster. You don't need that much time, but let's just use the default and run the trials since we have set up everything. Now, if you run this directly, you immediately see the challenge. The challenge being simulation can be really, really time consuming, right? Because each hour now you have 105 jobs surviving. If you need, for instance, 100,000 of customers, you need what? You need 1,000 hours. 1,000 hours is what? 60,000 minutes. It's dramatically shorter than what we have. So maybe we want to go back, and you can see from here, this generates 500,000 customers. So yeah, this, cancel this. Okay, we don't even have to look at this. We can click on OK to cancel this. And let's go back and adjust our warm-up period. All we can do is go to warm-up period. Right now, if I need 1,000 of them, I probably need what? Sorry, if I need 2,000. Then I need about 20 hours. 20 hours is 1,200 minutes. This is 100 jobs per hour. 1,000 will be 10 hours, 600 minutes. So 2,000 will be about 1,200. Okay, this. Go to results question period again. About 100 jobs per hour. If I need 100,000, sorry, if I need 10,000, right? That means 100 times longer. So 100 hours will be 60 plus that will be 6,000 minutes. Click on OK. Check make sure everything is correctly. Click OK. And now if I run our trial again, this is much faster. And it should be. Right, now we can calculate a number of things. The utilization rate now becomes 43.45%. The actual theoretical number is 43.75%. It's close enough, right? The average queue time is 0.118 minutes. And what we have here is 0.12 minutes. Again, it's pretty close. That's what we have. The average queue length is theoretical answer is 0.2065. What we have is 0.21. So it's almost spot on. Okay. And you may wonder, well, is it possible to find out the probability that the queue is empty with our P0, which we used to calculate all the numbers? Well, it's possible to explore if this is possible. To do that, we go to the queue, go to the results, and see if we're able to accomplish that. Now, if you look at all the numbers being collected, right, we have what? We have currently we have 0. Minimum we have 0 customers. On average we have 0.23. This is for the last one apparently, as I mentioned. Maximum is 12 items in the queue. And we have collected a number of things. And we can also have, well, what is the probability that you have waited less than 10 minutes. But it doesn't provide us to actually calculate the probability that the queue is empty or the system is completely empty. Now, there's one way to actually look at it. It's not going to be extremely accurate, but can at least give us something. So if we click on contents, it's showing me this diagram that we have seen. And you probably remember if we go to the results manager, if we go to home, results manager, so if we go to the all object results and queues, just give me 2 charts. Tells me the queue time distribution. Of the queue time distribution, we can get some sense about percent of the time we have no waiting and so on. And that means when you arrive, the system is completely empty, or at least one of the server is not occupied. But it doesn't give me that answer either. And so that's part of the things that you can find out. Well, indeed, in some cases, we need theoretical calculation to help us understand certain part of the system behavior. If you rely completely on the simulation software, some of the questions may not be completely answerable. And this is a perfect example to show that. So this basically gave us an MMC, or in this case equal to 2 MM2Q that we have discussed.